Solving systems of equations is just like solving regular equations, just it's a degree more difficult. Much like anything in Algebra 2. Because it's a degree more difficult, there's lots of different ways to do it. Each of these ways has a drawback to it. So over the next lesson or 3, I'm going to be showing you different ways to solve systems of equations. I'm also going to talk about their drawbacks. A system of equations is more than one equation containing more than one variable with more than one solution. What I mean is here you see an x and a y. Normally you're just used to x or just used to y. You could solve just for x or just for y and get an answer. In systems of equations, you're going to have 2 equations with 2 variables and have an x equals and a y equals, 2 solutions there. Well, I guess technically it's 1 solution. But this works for any number of equations with any number of variables. I mean, you can have 10 variables and 10 equations, and you're going to have 10 solutions. You're going to have an A and a B and a C and a D and all the way down to J. We're not going to get anything that tough. We'll do a lot of systems of 2s, a couple systems of 3s. I might show you a system of 4 later just for giggles. But really beyond that, you need some higher math to figure this stuff out, which I'll show you when we get to it. Now remember, this is notes, so everything I write down, you write down, and then you'll have it in front of you whenever you need it. What we have here is just something simple. X plus 3 equals 5. Obviously the answer is 2. 2 plus 3 would equal 5. Hopefully that's ingrained in your brain by now. Hopefully you didn't even have to think about it. You saw x plus 3 equals 5, your brain automatically went to 2. You should have overlearned that. It should be like reading. You can't look at a word and not read it. What I want to show you here is something that I don't know if you figured out yet, but pretty much all math teachers know. And that's an easy way of solving x plus 3 equals 5. An easy way of solving anything with one variable. You can graph it. Now, what you're used to is using slope-intercept form. What you're used to is y equals. There's no y here. So for many of you, this would be impossible to graph. But here's what you can do. Take each side of the equal sign. On the left side, we have x plus 3. On the right side, we have 5. And graph each one of those. Meaning, make the line of x plus 3. Make the line of 5. And wherever these 2 lines come together, their intersection, that's your answer. If you'll see here, x equals 2. We don't really care about the y, because again, there is no y here. Now this idea of graphing, this idea of intersection, works for virtually any equation. Anything you've seen in your math career so far, this works for. You can have this, graph the left side of the equal sign, graph the right side of the equal sign. Wherever those 2 lines come together, that's your answer. You can have this. Graph the left side of the equal sign, graph the right side of the equal sign. Wherever the 2 lines come together, that's your answer. Now, I'm sure you're groaning right now saying, why didn't someone tell me this before? Well, we didn't tell you this before because you wouldn't have learned it otherwise. You wouldn't have overlearned this. You wouldn't have looked at that original equation of x plus 3 equals 5 and your brain automatically went to the number 2. That wouldn't have happened if we gave you a calculator and said, don't worry about any math. Just hit these buttons like a monkey, and once you're done, it'll just spit out the answer at you. Like you wouldn't need to know math in order to solve this equation if we would have told you about this idea before. Now, how does this relate to systems of equations? Well, you're going to do the same thing. Like I said, I have to show you 3 different ways to solve these. The way I want to start with is the simplest, the way you really don't have to know much math for, but there's a lot of limitations to it. So we're going to solve these by using graphing. So again, write this down. This is notes. Y equals negative x plus 3. Y equals x plus 1. Up until this point in your math career, this would have been impossible. You cannot solve for both x and y at the same time, using the traditional method, using arithmetic like you've been taught. However, you can, like I just showed you with a regular equation, you can solve this by graphing. So here's what you're going to do. Graph y equals negative x plus 3 on one line. Y equals x plus 1, there's another line. And whenever they come together, that's your answer. Only in this case, we're not just looking at the x anymore because obviously these equations have both an x and a y. So your answer is x equals 1, y equals 2, because they come together at 1, 2. That's it. That's the way it works. That's how it can work for all of these. I'll show you again. Y equals negative x minus 2, y equals 2/3 x plus 3. It's another system of equations, a system of two. You have an x and a y. Graph both of these. Graph your y equals negative x minus 2, graph your y equals 2/3 x plus 3. Wherever they come together, in this case, negative 3, 1, that's your answer. X is negative 3, y is 1. That's it. When they invented this way of solving this type of equation, they didn't have calculators. It was all done pencil paper. So there's a little bit of a drawback there. Now, I'm assuming you have a calculator available to you. I'm assuming it's the TI-83, which we recommend. So let me show you how to do it on there, and then I'll start to discuss the drawbacks. All right, on a TI-83, what you'd have to do, obviously, is go to the y equals button. This will take you to the graphing. Type in what you got to type in. So let's go back to the original equation, or system of equations, the negative x plus 3 and x plus 1. Type in negative x plus 3 on one line, x plus 1 on another line. Hit graph. You should see this. Now, obviously, they come together there. Now, you can sort of estimate it a little bit. You can zoom in if you want. You can kind of count those tick marks. But you're going to want to be as accurate as you can. So if you go up to calculate, hit second, the yellow button, and trace. You go to calculate. You'll see a bunch of different options there. Go down to the fifth option, the intersect option. Hit enter. Hit enter again 3 more times. And it will give you the solution towards the bottom of the screen there. It says intersection x equals 1, y equals 2. That's it. And I'll show you again. Go back to y equals, clear out what you got. Put in your negative x minus 2 and your 2/3 x plus 3. You should see this. Now, just by looking at it, it looks like, I don't know, negative 3, 1? Maybe negative 4, 1? Again, it's kind of hard to see. Screens are kind of small. So you may want to, again, go to second, trace, intersect, hit enter 3 times. And it'll come up as x equals negative 3, y equals 1. And like I said, this works pretty much all the time. However, there are some drawbacks even to the calculator. One of the drawbacks is it has to be in y equals format. You're hitting the y equals button. It has to be in slope-intercept form. If it's not in slope-intercept form, it'll screw up. If it's not in slope-intercept form, you will have to do some extra work ahead of time in order to get into slope-intercept form, in order to get into the y equals, so that you can hit the y equals button and graph it. Also, if the numbers aren't round numbers, if they're not integers, it's hard to see what's what. So if you have an answer of, I don't know, 5/7, you're not going to be able to see that on the calculator. It doesn't give you fractions. Also, if you have a system of equations of more than 2, more than just an x and a y, you can't do it on a calculator either. And like I said, we're going to get to systems of 3, possibly more than that. So there's some definite drawbacks to this, but it is quick, it is simple, and it does kind of highlight the point of what I'm trying to say, which is every point on the graphical interpretation of an equation is an answer to that equation. And the intersection of 2 lines is the only answer to both equations.